to go over some of the steps required to do some advanced PLC programming. Today we're going to take you through the steps that will allow you to program a sequence of events to allow the bearing housing to be rejected. So with any PLC programming assignment, you must well prepare. One of the first things that you're going to need to have an idea of is your electrical schematics. The designer will have made the schematics for you with all the inputs and outputs on them, but it's going to be up to you to determine how those work. So here is our first page of our schematics, and this is mainly the power supply, which that doesn't really affect us too much for programming issues, except to know that the L1 and L2 connections here are being controlled by on-off buttons. So the next page is really important here. This is our input page. We can see that we've got 24-volt inputs that are being connected to this station. We've got I:20, which is our push button, and that again is indicated right here by the IEC symbol for a push button. And the next one here is our stop push button, and we know that that one is wired normally closed, so we'll have to take that into consideration when we write our program. Next one here is an auto manual switch, and we got a reset push button, and then all of the rest of these are indicators that are attached to the cylinders. It's a reed switch. Each cylinder inside has a magnet that when that magnet passes over it, it allows that sensor to be triggered. So if we look at the very first one here, I:24, says manipulator back, and that is referring to the cylinder over here on the actual station that places it backwards and forwards. So at this point I just want to go over a little bit closer with you. I:20 is the start push button, and I'm going to go ahead and push that right now. You can see it right here. This would be the push button. And our next one is our stop push button, and that's going to be located right here. And next we have auto manual, which is I:22, and this is a two-position switch, but it only has one address. So in one position you're going to get a signal, in the other position you won't get a signal, so you program accordingly. Our next button is I:23, and this button is going to enable us to reset the station should our actuators get out of control or out of sequence. And our next one is manipulator back, and the manipulator back is referring to this actuator right here. So when it is in its normal state, it is back. You can see that the actuator attached to here is in the back position. Manipulator forward, which is the next input, which is labeled I:25. Manipulator back and manipulator forward, I:24 and I:25. So when this cylinder energizes, it's going to take this out here and back and forth. That's why they labeled them accordingly. Our next input is manipulator up and down, and that is I:26 and 7. I:26 is in the up position, I:27 is in the down position. And the next one we have is I:28, which is a vacuum sensor here. So when the body is actually attached here via vacuum, this sensor here is going to be triggered, letting it know that it has vacuum present. And the last 4 or 5 on here, we have verify forward. This is a verification cylinder, and it checks for bodies that either have the correct orientation or the incorrect orientation. So it will only fit in there one way. And that is verify forward, and that is I:29. And the sensor for that is right here on the side. Next one is I:210, which is the pusher forward. And right here is the signal for that. And our next one is the feeder forward and backward. This is the feeder forward cylinder. So if we looked at this input right here, when this cylinder is forward, this one would be on. And the next one is I:11, which is feeder backward. And we can see that this cylinder right here is already on, and it is illuminated because this cylinder is backward. This being backward, and of course this being forward. So each one of these stations has an input on them. You can see some that are illuminated right now, okay, indicating the actual status of these actuators. So it's going to be very important that we look at our documentation on our schematics to be able to map that to the PLC program.